this video, we look at using Visual Basic for Applications, VBA, to create custom Excel functions. VBA is a programming language that underlies many of Microsoft's products, including their Microsoft Office applications. It also underlies Microsoft Dynamics, which is their accounting information systems line. Therefore, learning to work with VBA creates a great deal of options for you in terms of creating customizations not just for Office applications, but also for accounting information systems applications. Let's take a look at a method of calculating depreciation that we often examine in Intermediate Accounting 1, but it used to be covered in Introduction to Financial Accounting. If you haven't had Intermediate Accounting 1, don't worry about it. It's a fairly basic method. It's not much more difficult than straight line depreciation or some of the years, double declining balance depreciation. But this method is called the sum of the year's digits method. Oftentimes referred to as just the SYD method, sum of the year's digits method. And this method, like other depreciation methods, requires a few key inputs. One is the cost of the asset, which I will just designate C. And basically we're going to be allocating a portion of the cost of the asset to expense through this depreciation process. Another thing we need is the estimated useful life. I'll just designate that L. We can also have the estimated salvage value. So estimated salvage value or residual value. Those terms are used interchangeably. I'll use R to represent it, but the estimated residual value is the amount that the company anticipates that they will be able to obtain from the asset, maybe upon some form of disposition, say selling the asset outright or trading it in for another asset. But it's the amount they obtain, the amount of value they estimate that they will be able to obtain at the end of the asset's useful life. Another item that we will need here will be the acquisition month. And the reason we need that is that unless the asset is acquired at the very beginning of the year, then for the first year we only want to take a fraction of the year as depreciation, or a fractional year amount of depreciation based upon the length of time that the asset was actually held. So I'll use the letter M to represent that. So let's assume some amounts here. Let's assume we've got an asset that costs us $100,000. Let's assume it's going to last us 5 years. And let's assume that at the end of that 5-year period, we anticipate that we will be able to sell it for $10,000. Let's also assume that the asset was acquired, say, in the month of April. That would be month 4, of course, for a calendar year company. And we will follow the convention of taking a full month of depreciation in the month of acquisition, regardless of at what point during the month the asset was actually acquired. Okay, so with that, let's calculate a couple of intermediary amounts that are essentially derived from our inputs. One thing is called the residual, or rather the depreciable cost. Okay, so the depreciable cost that will be equal to, and I'll use the letter, say, just for lack of anything else to be able to use here. I've already used C. I'm going to use D elsewhere, so I'm just going to use Y to represent that. Okay, and that's going to be equal to our cost minus our residual value. So in the context of this problem, that is 100,000 minus 10,000, the two inputs that we have here and here. And of course that will be $90,000. And that basically represents the total amount of depreciation that we want to take over the useful life of the asset, because we depreciate an asset down to its residual value but not below. Alright, then we need what is referred to as the sum of the year's digits. Sum of the year's digits. Again, I'll refer to that as the SYD. The SYD, basically, say for an asset that's got a useful life of 5 years, it is 5 plus 4 plus 3 plus 2 plus 1. In other words, you begin an arithmetic calculation with the estimated useful life, 5 in this example. You step down 1, so you go 5 plus 4, then again 3 plus 2 plus 1. And a shorthand way, we might say, or a shortcut way of calculating that is by taking the life of the asset times the life plus 1 dividing by 2. So in the context of this problem, this would be 5 times 6 divided by 2. That's 30 divided by 2, which is 15. And you can verify that that is the same as 5 plus 4 plus 3 plus 2 plus 1. Okay, well, armed with that, let's compute our depreciation then for the first year. I'm going to say D sub 1 as the depreciation for year 1. And just to kind of write this out in terms of our basic variables, we want to take the depreciable cost of the asset. Recall I designated that as Y up here. And we want to multiply that by a fraction, the denominator of which is the SYD. The numerator is the year number in reverse, say reverse order. And then we're going to prorate that by the fraction of the year that the asset is actually held. So a year has 12 months, as we know. And as we kind of would note here, if we acquired the asset in April, we want to begin depreciation at the beginning of April and take depreciation for all that month and then through December. That's 9 months. And so effectively that would be 12 months minus 4 months plus 1. Okay, so it's 12 months minus the number of the month of acquisition. But since we want to back that up to the beginning of the month, we add 1 to basically capture that. If we didn't add the 1, we would basically be beginning our depreciation on May 1st. But by adding the 1, we're effectively backing the depreciation up to the beginning of April. So that will give us the fraction 9 over 12 then. So once again, for year 1, our depreciation will be $90,000. That's our depreciable cost. The year number in reverse order will be 5, so we begin with 5. The asset has a 5-year useful life, so we begin with 5 and we put that over the SYD, which, as we determined up here, was 15, and we will take 9 over 12 months as our fractional year amount, and so that will give us $22,500 for the first year. Okay. And now, as we step then to the second year, we'll calculate depreciation. We'll call this D sub 2, using, again, the subscript or the index to indicate the year number for which we are computing depreciation. One thing we'll have to remember is that in this method, we always use a particular SYD fraction for a full year. We've only used that fraction, as we see, for 9/12 of a year. So we have to complete a full year using 5 over 15 as what we call the SYD fraction. So our depreciation for year 2 begins again with our depreciable cost, 90,000. We're going to use that same fraction up above, 5 over 15, but we want to complete out a year using that fraction. So we'll pick up the other 3 months to take us to a full 12 over 12 months of having used 5 over 15. Well, that only gives us depreciation for the first 3 months of the second year. So to capture the depreciation for the remaining 9 months of the year, we again take our depreciable cost. We now step to the next year as the numerator of our SYD fraction, which will be 4 over 15, and take that for 9 over 12 months. And that will actually work out to, as you crunch through the numbers there, $25,500. Okay, so that sets up a pattern for us. We'll, just for sake of further illustration here, let's compute depreciation for year 3. Again, begins with our depreciable cost, $90,000, times 4 over 15 this time. Again, we're looking to complete the year, a full year, using that fraction, so times 3 over 12. And then we step to our next SYD fraction, which is 3 over 15, for the remaining 9 months of that third year, and that will take us to $19,500. And we could move on and calc a depreciation for years 4, 5, and actually 6. You would, even though the asset has a useful life of 5 years, since it wasn't acquired at the very beginning of the first year, you actually wind up taking some depreciation in 6 years. And so what we want to do now is kind of take a look at this calculation and see really what's working here, and see what we might do from the standpoint of perhaps developing our own function in Excel that will allow us to automatically do this calculation. As you see, this calculation gets kind of laborious in terms of year-to-year calculations and so forth, and if you had several different assets for which you needed to figure depreciation under this method, it could get quite involved. So we could simplify the task greatly if we had a function in Excel that we could just simply feed parameters to, such as our costs, our residual value, the estimated useful life, and the acquisition month. If we can feed all those values to a function in addition to the particular year number that we want to compute depreciation for, then that would greatly simplify life, you might say. So that's ultimately where we're headed here. I'd like for us to take a look, though. Let's focus on this second year of depreciation, because the first year involved only one of these calculations where we were taking the depreciable cost and multiplying by an SYD fraction, and then multiplying by a fractional part of the year. Let's focus on year 2, and then we'll back up to year 1 and see how things, how we might capture a similar set of computations for year 1. First of all, let's note here that we've got a subscript here representing the particular year that we're computing depreciation for. We're going to make use of that in some things. First of all, in terms of this SYD fraction, this year number in reverse order, if we notice that for year 2 it's 5, for year 3 we're looking at the number 4, and so forth. Let's use that year index, 2 for the second year, 3 for the third year, to give us effectively an equation that we can calculate what that numerator is. If we think about it kind of logically here, this would be the useful life of the asset minus that year index. I'm going to use the letter I to represent that index. So in the second year, I is equal to 2. In the third year, I is equal to 3. So if we were to take the useful life and subtract I, and then add back 2, that would give us that numerator. For example, in this in year 2, that is 5 minus 2 plus 2. So that does in fact give us 5. But notice as we go to year 3, following that same thing, life minus I plus 2, since the life still is 5, but now I is equal to 3, then we add back 2, that will give us 4. Okay, and we can follow that through then to later years. So that basically gives us a little expression that we can use to automatically calculate that numerator. We already know how to calculate the SYD. That's up here. So we can use that also as we develop an Excel function to compute that denominator. Just keep in mind that's our SYD in that denominator. Now another thing we want to look at here would be these time weights that exist in this calculation. Notice that they're the same in each year here, except for year 1. Year 1 basically it's that second time weight that we effectively begin with, and we'll consider that in just a moment. But I want to give this first fraction a designation, and let's call this time weight 1. Okay, time weight 1, and then logically we'll call this time weight 2. Okay, and let's see if we can just kind of write an expression for that could be used generically, so that regardless of what the situation is, we can pass maybe the useful life of the asset into a function and use that to calculate, or the acquisition month, and use that to calculate the time weight. So we'll see if the acquisition month was 4 here, as we indicated here, the month of April, then that numerator is 3, which is 1 less than the acquisition month. Recall I called the acquisition month M here, so basically that's going to be M minus 1 over 12. All right, and we see that in the context of this problem, that's 3 over 12. That evaluates to 25%, and you'll see that the second time weight, given that basically the two fractions add to 1, is just the complement of that. So we could set this time weight 2 as basically 1 minus time weight 1. So in other words, if time weight 1 evaluates to 25%, or 0.25 as it does in this problem, we saw that time weight 2 evaluates to 9 over 12, or 75%. So it's the complement of that. So we can use that relationship as well. So I guess another thing we do need to mention here is regarding the second fraction then, here, the second SYD fraction. If the first SYD fraction was L minus I plus 2, the second SYD fraction would be L minus I plus 1. Okay, L minus I plus 1. So that we see that for year 2, when I is equal to 2, you've got 5 minus 2 plus 1, which gives you 4. And then for the next year, it is 5 minus I being equal to 3. It's 5 minus 3 plus 1. Not I, but 1. Try to get my eraser going there. There, okay. Plus 1. Okay. So that'll be 5 minus 3 is 2, plus 1 gives you 3. Okay. So armed with that information then, we can take these ideas to Excel and basically create our own function, create a function that we can pass certain values to. In fact, the key things that we want to pass to our function will be these essential inputs. We want to pass in the cost, We want to pass in the estimated useful life. We want to pass in the residual value, the month of acquisition, and then also the particular year for which we want to compute depreciation. Okay. Now it's worth also mentioning here, year one is a little different than the other 2 years in that you only have one instance where you're taking the depreciable cost, multiplying by an SYD fraction, and then multiplying by the second time weight, or time weight 2. Now to create a situation so that we don't have to separately calculate the depreciation in a different manner for year one than we do for year two, we could create a scenario where we've got essentially the entire calculation where we're taking 90,000 and multiplying by some fraction and then multiplying by 3 over 12 and then adding that to that second calculation. But essentially we want to create it in a manner where this first part of the calculation falls out. And we can do that by making that, we might say that SYD fraction being 0. That first SYD fraction being 0 for the first year. Okay. So we've got effectively year to year, we've got effectively 2 SYD fractions that we want to use. And we might call them SYD fraction 1 and SYD fraction 2. But we've got the formula, say for the first one, the numerator divided by SYD. And that all works except for year one when we want a special case where that's simply going to be 0. Okay. And we will be able to capture that basically in what's called an if function in our Excel Visual Basic for Applications function, as we will see. But anyway, the idea again is what we're going to do is pass into an Excel function that we're going to develop our key inputs: the cost, the estimated useful life, the residual value, the acquisition month, and then also the particular year for which we want to compute depreciation. If it's year 1 or year 2, basically we'll call that the year index. Okay, so those will be our 5 inputs, okay, to this function: cost, useful life, estimated residual value, acquisition month, and then the actual year for which we want to compute depreciation. So as we do this, keep in mind these amounts that we computed in this example for our depreciation, because, oops, I didn't mean to mark through that, but mark around that. We computed 22,500 for the first year, 25,500 for the second year, and 19,500 for the third year. So we'll be able to check our results from the function that we develop in Excel to see if it actually works. If it's working correctly, we should be able to get the same amounts that we obtained here. Okay, what we want to do now is look at how we can use Excel to develop our own function that will compute our sum of the year's digits depreciation for us. Now, Excel actually has an SYD function built in. However, as we'll see, that it doesn't quite do exactly everything we want it to do. If you go to hit the functions button up here, and in the financial section and scan down, you will see that there is again an SYD function, and when we click on that, it tells us the form of the function. It's again, we invoke it with an equal sign and SYD, and then we feed it 4 parameters. We feed it the cost, the salvage value, the life, and what's called the PER, the periods, the actual period for which we want to compute depreciation. That would be a year number. And this function will compute SYD depreciation. The only problem is that it does not do the partial year calculations as we just reviewed in the example that we went through. And you can still use Excel's SYD function, but you've got to go through some gymnastics to basically make it do what you want it to do. And I've used the function here. Basically what I've done is, to save a little time, I've gone ahead and set up our example here in Excel where our primary inputs to the SYD depreciation computation are here: the cost, the useful life, the residual value, and the acquisition month. And basically I've used the SYD function. If you hit F2, of course, it'll show you how what cells are being fed into the function. I'm feeding in again the cost and the useful life, the residual value, and the acquisition. Actually, the acquisition month's coming over here in a calculation that I've appended to this function so that it will compute a partial year of depreciation. But the last thing I fed into the function itself was the particular year number that I wanted depreciation computed for. And so again, if you've got an asset that was acquired in the month of April, you only want to take a fractional part of the year's depreciation amount that year. And so what I did was take 12 months, subtract the acquisition month 4, and add 1 to that to basically give me the fractional year that I wanted to take. And again, divided by 12. And notice in the SYD function itself, I fixed the cell references by putting the dollar signs in front of, say, B1, cell B1 here, so that I could copy the formula down, that kind of thing. But as I went to the second year, you see my calculation got more involved because of the split year calculation, as we illustrated in the example a few minutes ago, where you've got to first calc depreciation for the first part of the year. And I'm doing that basically right in here, okay, right in here. And then I'm calculating depreciation for the second part of the year right here. So in terms of an Excel formula that we've entered here, it gets quite involved to actually make that happen. And what would be really nice is if we could simply feed all 4 of these values along with our year number to a single function and have it give us the result that we want. And so we're going to do our own Excel function here and compare the results with what was obtained by using Excel's built-in function. Okay, now to make this work, or to be able to do this, you have to have certain features in your Excel desktop application turned on. So if you go to File, and then at the bottom of the ribbon on the left side, go to Options. There's a couple things we want to look at. One is add-ins. So if you click on add-ins, you'll see down at the bottom here where it says Manage, and you could do a drop down here. There's different types of add-ins and so forth, but Manage Excel add-ins, and if you just hit Go there, you'll make sure certain things are checked here. And this just turns on certain functionality that this kind of by default is turned off. The main two would be the Analysis Toolpack VBA. I have my solver turned on as well, and you might go ahead and click that on because we might actually use the solver this semester in some of our analysis and so forth that we might do. But just hit OK, and then let's again go back to File and to Options, and let's look at Trust Center. Okay, now having activated Trust Center, we can come over here to the right to Trust Center Settings, and there's a couple things we want to do here. One is look at our macro settings. Okay, and in that, let's make sure that we have at least disable all macros with notification being checked. Probably in default, it will be disable all macros without notification. That will be active, but you want to make sure that this is active here. Disable all macros with notification. And you could, if no one else is using your computer, that sort of thing, you could just go to enable all macros, but as they notice, not recommended. Potentially dangerous code can run. But then also check the trust access to the VBA project object model. That'll allow us to develop our applications and basically have Excel trust the applications that we've developed ourselves. So anyway, with those two things done, hit OK. And all the way through, get back to your main spreadsheet here in the home page. And now what we need to do is activate the key sequence Alt F11. Alt plus F11, okay, your function 11 key. So hold down your Alt key and hit F11. And that will bring up a new window. And this is called the Microsoft Visual Basic for Applications Editor. And this is where we can effectively build subroutines that do special things for us, and that's really where we want to go ultimately with this, in terms of building special applications that will perhaps maybe extract data from an accounting information system database, do some manipulation of that data, and maybe perhaps even write it back to the accounting information system database. But right now we're just going to write a function that we can invoke in our basic Excel spreadsheet. And so you've got the Project Explorer over here, and really what we're operating in right now is the open book. I've just got this book 1 here, since I haven't actually saved this file as anything. It's got default 1 as or book 1 as the default name. And what I want to do is go up here and insert a module. So say with VBA Project Book 1 highlighted here, okay, highlight VBA Project, the actual name of the spreadsheet that you're in now. You can do two things. You can either go over here and do the drop down and select module by this little icon that appears here, this little designer icon that appears here, or you can say insert module. Either way, what that does is give us a white field over here in which we can work. Okay, and let's begin here. This is where we're essentially going to write in what's called the Visual Basic code that will drive our function. Let's begin by typing the word function. And then we want to give our function a name, something that when we enter a formula in Excel, it makes sense, we know what it is, and so forth. Now, we can't use the same names that Excel has already captured in its built-in functions. Recall, it's got an SYD function already. So I might call this my SYD, okay? My SYD. And then, in parentheses, I want to indicate the names of the parameters for which that I want to pass values into from the Excel spreadsheet. And so we might just use the word cost here, since we want the cost of the asset. And I'm going to add an indicator after each variable name as to what type of data that variable or that parameter will receive. And it said that we are dimensioning, the terminology is we're dimensioning our variables. And notice that as I begin typing here, the Excel VBA editor brings up certain options that are available to me in what's called IntelliSense. In other words, it senses what is coming next in the code and gives me a drop-down menu that will help me complete that code if I want to. Actually, I wanted to mention this as currency. Okay, it'll be a currency field. And there's a dollar amount that we're feeding in to this function as the cost of the asset. I can just hit tab there and it brings in the word. I want a comma now, and I want to bring in my next parameter. These can come in any order we want. Let's bring in the useful life, I guess. Now, Excel does not, in terms of your variable or parameter names, it does not like spaces. You can use mixed capital letters and lowercase letters, that kind of thing. And if you wanted actually a space, in lieu of the space, you could use an underscore But what I typically do is just simply use a capital letter for a word name to begin a word, and you'll see here in the case of useful life, I've got capital U and capital L, but I've sandwiched it together as basically a single word, useful life. And this would basically be, typically speaking, we specify useful life in terms of whole years. So we can dimension this as an integer. So I'll just say as int, and so notice it automatically has brought up integer. Hit tab to bring that in automatically, and then I need my residual value. So notice that again, I'm just kind of sandwiching it all together as a single word, residual value. This is also a dollar amount, so I want to dimension that as currency. Okay, and recall that we need also the acquisition month. Now these variable names, you can call these anything you want to. In fact, you can use single letters if you want to. You can use C for cost or something else. So there's nothing particularly special about me calling this, say, acquisition month. But the acquisition month, given that it's the number of the month in which the asset was acquired, that will also be an integer. Okay, so we can dimension it as an integer. As we'll see, basically in Excel VBA, and VBA is a programming language that cuts across Microsoft, not just Microsoft Office, but also underlies a lot of Microsoft's other products. In fact, Microsoft has an accounting information system called Dynamics, and there's Dynamics GP, there's Dynamics AX, there's several different versions of Dynamics. But essentially, Visual Basic for Applications underlies not just Microsoft Office, but also Microsoft Dynamics, its accounting information system. So learning to do a little bit of programming in VBA will not only allow you to develop special functions, say in Excel, or special applications in Excel or Microsoft Word or a Microsoft Outlook, that sort of thing, but you can also customize the Microsoft Dynamics accounting information system with it. You can build special windows, special applications that run in that accounting information system. So this is a very useful tool for an accountant to know. I need to complete this out here. So we had the acquisition month as integer. Then we also want to pass in the actual year number for which we want to compute depreciation. I'm going to call that the year index. And again, that'll be an integer as well. So dimension that as an integer. So now, again, as I mentioned here in VBA, we'll indicate the type of variable, whether it's currency or integer, that sort of thing. That's said to be dimensioning the variables or the parameters. And as we'll see, there are certain ranges that certain dimensions are allowed to take. And well, we can discuss that perhaps in a later video or a later lesson, but there are other dimensions. In fact, we'll even see one or two others in this application that we're developing here. But the overall result set then is going to be returned through this function called mySYD, and we also wanted to mention that. So essentially we're returning a depreciation amount. So since we're returning an amount that is basically a dollar amount, we will also dimension this as currency. Okay, so that's dimensioning basically the mySYD as currency. So we've dimensioned, we've specified the parameters that are being fed into the function here, we've given them a name, and we've indicated what type of data is stored in those parameters. It's currency values or integers basically is what we use so far. And the overall result that we calculate will be returned through a variable called mySYD that we have then dimensioned as a currency value as well. Now, and when you hit enter, notice it's highlighted certain keywords here in blue. Other things that are not keywords are left in black, and it's automatically added the statement in function, which is the terminating point for this particular segment of code that we are going to develop here. So effectively, we can add spaces. You can hit your enter key and add spaces to give you some room to work here. And what we want to do after this then is perhaps to mention a few other variables that we're going to be using internally in this function. Okay, so I'm going to use the keyword dim or dimension. You could spell it out as dimension, but typically we just say dim for dimension. We're going to set forth, or we're going to specify certain other variables that we're going to use in our calculation. Recall that the cost less the residual value was an amount that we call the depreciable cost. I'm going to set that up as a variable. Just call it depreciable cost, and dimension that then as currency. Okay, and then we've got an amount that we'll just call the SYD that we will dimension as an integer. And then, as we kind of saw in the initial example we went through, as we had the split year SYD computation, we're going to have one SYD fraction that we use for the first part of the year, and then we've got another SYD fraction that we use for the second part of the year. So I'm going to call another variable the SYD fraction 1, and that will be of a new variable type. That basically we want this to be a decimal type number, and a good dimension for that will be the dimension single. Okay, so we'll dimension that as single. We'll also dimension SYD fraction 2 as single. And recall also in this split year calculation that we do, we have two separate time weights. And so for the first part of the year, we're going to use one time weight, say 3/12 months, and then the next part of the computation we use another time weight. So I'm going to call another variable time weight 1, and since that is a fraction, we will also dimension that as single. Okay, and then we've got time weight, let's spell it here, time weight 2 as single. All right, well, given that, I think we have all the variables set up that we're going to work with. I'm going to drop down to another line now. And actually, what I did was I don't need the equal sign up here. That was an extraneous character. So if you make an error in typing, the VBA editor lets you know very quickly by highlighting the line in red. So anyway, you don't use an equal sign there, but so you just basically specify the name of the variable and how you're dimensioning it as currency, as integer, that sort of thing. Now then, I'm going to say initiate the variable depreciable cost by just basically setting forth an equation here, depreciable cost being equal to, since by the time we hit this line of code, we've already fed in variables for cost and residual value. We can then work with those. We say it's the cost minus the residual value. And another item that we want to calculate is the SYD. Recall in the example we went through, we said that, well, that's basically the useful life plus 1, or useful life times the useful life plus 1, all divided by 2. So we could do something like this. We've got the variable useful life that we can that we're passing in the value to here. So let's take that variable. Let's multiply that. Now in Excel VBA, the multiplication is sign, or the time sign is the asterisk. So use the asterisk times useful life plus 1. Okay, make sure we've got our parentheses all lined up correctly and we've got the same number of left and right parentheses, and then divide that result by 2. So that was our SYD. Then we've got our SYD fraction 1, which, recall that this was going to be basically a useful life minus the year number for which we're computing depreciation plus 2, okay, divided by the SYD. However, if it were year 1, if it's year 1, basically we want the SYD fraction to be 0. We're going to use a special function in VBAs called the if. That this works much like the if statement in Excel, whereas noted here we can pass in an expression that we will evaluate whether the expression is true or false. If the expression is true, there's the true part that will then calculate or be determined. If the expression is false, the control passes to that part and we will determine what the value would be in that set of circumstances. So the expression that we want to evaluate is whether the year index, say the year number, which we're calling the year index, if that's equal to 1. If it is equal to 1, we want the value of our SYD fraction 1 to be 0. If it is something other than 1, we want it to be the useful life minus the year index plus 2, and then we want to divide by the sum of the year's digits value, the value in that variable that we just calculated here. So you have to follow it in certain order. You could not do this before you did the previous statement. You have to have the SYD value determined, and then you can basically calc the amount for the SYD fraction 1. Okay, so having done that, we've got our SYD fraction 1. We've got then the SYD fraction 2 that we want to compute, and from the example that we went through, we saw that that was going to be the useful life minus the year number or the year index plus 1, and then we were going to divide that by the sum of the year's digits. Then we've got our time weight, so time weights. So time weight 1 was going to be equal to the acquisition month minus 1 divided by 12. Okay, so if we acquired the asset in April, acquisition month is 4. Again, basically we want to take as our first time weight, we want it to be 3 over 12. So we're subtracting 1 to take it to 3, and then divide by 12. And then time weight 2 was, as we noted, is the complement of time weight 1. So having calculated in the previous command here the value for time weight 1, we can use that and subtract it from time weight from 1. So time weight 2 will be 1 minus time weight 1. Okay. Now, with all that, we can finally calc the value of my SYD, which will be, again, basically the single output of this function that will be fed back to our Excel spreadsheet. My SYD is going to be equal to the depreciable cost of the asset times the SYD fraction 1 times the time weight 1. That gives us depreciation for the first fractional part of the year. Then for the second fractional part of the year, we take the depreciable cost. We multiply by SYD fraction 2, and then times time weight 2. Close our parentheses. Okay, so at this point it's typically a good idea to spend a moment or two just looking back over your code to make sure you didn't make any typographical errors, because VBA, like other programming languages, is typically fairly unforgiving of typographical errors. And I did notice back here that when I entered the expression for our SYD variable that I wrote the variable use life. I meant to say useful life, and then so it's good to catch that. Otherwise, basically it would interpret that as a completely separate variable, and then basically that would have had a null value or a zero value that then would have effectively caused an error. It would have a null value rather than a zero value, and therefore the function would have crashed. Another thing is like lengthy words and so forth. It's things that are sometimes easy to misspell. You might key in on those. Notice here that acquisition month is the name of one of my variables here, and I use it down here, and I notice that I did actually leave the C out there. So anyway, there's a way to, if you attempt to execute the function and it doesn't work, there's a way to basically help isolate where those errors might be, and we might look at that. But let's first see if this works at this point. And let's go back to our Excel spreadsheet. And so in our cell here right beside where we used Excel's built-in SYD function, let's try to invoke our new function. So I'm going to go up here to where it says insert function. I've got the function symbol there. If you do the drop down here, again, you have several categories of functions, but if you look under my or user defined rather, you'll find my SYD as the function we just wrote. And so I'm just going to hit OK. It'll bring up a form here, and we can then reference in our variable values. There was our cost from cell B1, our useful life from cell B2, our residual value from cell B3, and our acquisition month from cell B4, and then the year index will be what right now appears in B8. And I'd like to make it to where the first 4 cell references here are fixed, so that as I copy the formula down, those will not automatically change with the copy down operation. So we can lock in the column by putting a $sign before the column designator. We can lock in the row by putting a $sign in front of it. So I'm going to do that on the first 4 variables. That basically fixes those as we copy our cell down here in just a second. But now this next one, I might want to fix the column but not the row, so that when I copy it down for the next year, it's going to reference cell B9 instead of cell B8, that sort of thing. So I'll hit OK, and notice that we get the same value that we got when we calc this under using Excel's SYD function. I'll copy it down, and so again you'll notice the simplicity, if we're looking up here in the formula bar, of the my SYD function invocation versus what we used here using Excel's built-in function. So it's just a lot easier having built that function that does what we want it to do, to calculate on the basis of partial years and so forth. We can then use that function in other spreadsheets and calculate some of the year's digits depreciation on multiple sets of assets, and that'll be a lot simpler than using the built-in Excel SYD function. So we've determined that our function works as is intended. I'll just kind of go back here to our program, and I would like to mention here that you can add comments in your coding as you would like to. To do that, say to add a line of comment, you can hit the single quote, and then anything that appears in that line after that will be interpreted as a comment. So it's basically a non-executable code. So I oftentimes like to kind of segment my code and indicate what follows. So the next line after this is the dimensioning of our other variables. So I might just simply say that dimension additional variables. So after our function line, we put a comment in here indicating that what appears after this. In the function line, we indicated the variables or the parameters that receive passed-in values from the Excel spreadsheet. But then we had other variables that we used in the internal workings of the function itself, and so we had to dimension those here. And then after that, when you set the values of your variables, either as explicit amounts, hard-coded amounts, or by reference to the values of other variables, this is referred to as variable initialization. You are initializing these variables for use. You're putting values in them. So that's what's happening here is, we'll just say initialize variables. Okay, so again, that's just a comment line. It doesn't do anything. So basically, we are initializing variables, setting variables equal to either explicit amounts or a combination of other variable values here, all the way really down to this point. And then we might say the next line is where we basically compute the value of the return variable being the my_syd. So I'll just simply say that, compute or return variable computation. Okay, so with that we have our 3 comments in here, and again we can basically add additional comments if we want to make the code understandable. It's oftentimes helpful if you later have to come back maybe a few months after you've done something and make a change to it, to have these comments in. It'll make it more efficient in terms of figuring out what you did. And anyway, so and we'll notice back here in our main spreadsheet that adding those comments didn't affect the execution of the function at all. So at this point, I think what I'd like to do here is show you how you might detect an error if there is an error in your coding. Let's just go back here, and I'll just go back to this one cell here and leave it active. But remember, I had misspelled acquisition month in here, so let's go back and put that spelling error in there and take that C out, so that basically this is not the same as this up here. And let's go back to our spreadsheet, and I'll just click on the formula here and so forth and hit enter to reactivate that. Notice that when I did that, I'm now getting an amount different than what I expected for year 1. And that would tell me that if I get a different amount than what I expected, or I actually get an explicit error message here, that tells me there's something wrong with my coding. So one way, when you detect that there is an error in existence, one way to locate that is to put a stop in the code at some point. And you can do that by going over here in the gray shaded area of the VBA editor window and simply clicking where you want to put a stop. Okay, now I just clicked by, since this was a fairly short program, I just clicked by the last command of the function, which was the end function command, and basically it will cause all the code before that to execute and will not execute that end function. So basically the program stops at that point, and we'll see what it will allow us to do. So I'm going to again kind of go up here and make that active as I click on the formula, and I'll hit enter. and notice that it automatically kicked me back to the VBA editor. And what this allows me to do, as we see, will be that I can hover my mouse pointer over my individual variable values and see what's currently in those. At the point the program stopped, what is the value of these variables? Well, the cost is what I expected, 100,000. As I passed that in, the useful life was 5, the residual value 10,000. The acquisition month showing up there is 4. There's the year index is 1, so I'm saying, well, all those have values as I expected. Even my depreciable cost computes to 90,000. And since this was year 1, I did expect the SYD fraction 1 to be 0 because of this if command that we had in here. So if year index is equal to 1, we want it to be 0. If not, we want it to calc to something else. So we expected, since year 1 was what we had as the input for this particular execution of that function, then that was okay. It looks like my SYD fraction 2 computed correctly. It's useful life minus year index 1 plus 1. And then divided by the SYD, which is 15. And then I get down here to time weight 1, and I say, wait, now this variable is showing to have a negative value. I know that can't be, or should not be. And I say, well, why is that? And I say, well, the problem's over here on this side of the equal sign, most likely. I hover over that, and notice it says acquisition month empty. And I say, well, wait a moment here. I went up here and I saw that acquisition month is 4, and what we're doing now is determining or displaying what the value of these variables is at the point that the program stopped execution. So I would have expected both of these to have the same value if they are in fact the same variable. Well, that tells me, well, there's some difference here between these two, and I start examining the spelling then at that point. And I say, oh, I left the C out of here. So technically speaking, these are not the same variable because I spelled this one differently. Again, VBA, like other programming languages, is fairly unforgiving of typographical error. So that tells me that's where my error is. I need to make the correction there. What I'm going to do here is stop, you might say reactivate the program by setting reset up here. That'll remove the yellow coding there, or the yellow shading. And then I'm going to remove the stop by simply clicking on the red dot again. I can go up here and make my correction, change that to a C. Okay. Go back here to this function. I can activate it again just by clicking on the formula bar, the formula in the formula bar somewhere, hitting enter, and notice it brings back my value as I expected it to. And so anyway, that's a useful thing when it comes to doing this Visual Basic for Applications coding, because you'll invariably make some typographical errors and have to go look back through and find out where they are. And being able to put a stop in the program at a particular point is a way of fairly quickly isolating where your problem might be. So I would encourage you at this point to try to open your program of Excel, do the initial setup as I indicated there through the options, and then go to the VBA editor. Again, it's Alt plus F11 that'll get you there, and try your hand at entering this code and then invoking the function that you wrote, just like you would any other function in Excel. Pass some values into it and see if it computes as you would expect. So again, the writing of a function, using VBA to write a function, is just one thing that we want to become familiar with. The more widely used thing will be the writing of what's called a subroutine that can do just many different things for us. And one of the things we're going to focus on ultimately is using a subroutine to extract data, say from an accounting information system, do some sort of manipulation of that data, and write it back to the AIS database. So quite a bit left to come on this. There'll be We can bring in other programming languages with this and we're going to do a little bit of that. We've got a language that we use to extract data from a database called SQL. And we're going to work with that some and basically build that into some of our VBA coding. Anyway, this is all very useful stuff and very applicable to accounting information systems.